am audible to you. And can you please check whether the slides are changing?
Yes, ma'am.
All right. Okay. Uh, First, let me introduce myself. I am Madangi Krishnadasan, lecturer at UCSC. So I'm going to deliver 2 lectures in security of NoSQL databases. So today I'll cover uh, what is an NoSQL database, and I'll give you an introduction about what is NoSQL, what are the different types of NoSQL databases, and the difference between an SQL database and NoSQL database, and what are the challenges that could be possible in NoSQL databases. So we'll cover those aspects in today's class. And in the next lecture, we will cover the security aspects of SQL, NoSQL databases. All right. Okay. Let's start.
Recording in progress.
Okay. First, what is NoSQL database? Are you all familiar with the term NoSQL? Did you ever come across with the term NoSQL when you're studying about databases in your first year? Anyone? Or is this completely a new term for you? You can even send me a message. That's fine. Are you all familiar with the NoSQL, or this is the first time you are hearing this term NoSQL?
Not in the lecture, but in industrial, I heard this.
All right. Okay, great. So let's try to understand what is a NoSQL and actually why we need a NoSQL compared to a SQL or the relational database management systems that we are using, right? Let's see. First, in order to understand why we need an NoSQL, first we have to brush our knowledge in relational database management system. So you all aware about relational database management system, right? You might have a subject, you may familiar with the relational databases in the industry. Many applications are developed with the support of relational database management systems, right? Okay. So what is a relational database management system, first of all? So relational database management is used to store the structured data, right? What we call as structured data. For example, if you're trying to describe a particular data, if you have a finite schema, that means you have a defined schema. For example, if you want to store the user details, you know, okay, what are the user attributes that you are going to consider in order to store the user data, right? Okay, so likewise, there is a predefined schema. They have a structure, right? We are using tables in order to represent the relational databases. All right, all these things are very basic stuffs you were already aware about. All right, when it comes to a table, usually table will consist of two major aspects. One is rows, or you can call them as tuples, or another one is attributes, right? So when it comes to, if you see this example, so there are 3 tables. One is for students and one is for takes course and course, right? So if you want to represent a relationship where student take courses, then you need 3 different tables to store 3 different types of information. One to store the student details, another one to store the interconnection between student details and courses details, and finally the course details, right? So all the data tables that have a predefined structure with the predefined attributes, and each attributes have constraints The constraints are, you might study about constraint, right? Domain constraint. Those constraints allow us to define the permissible values to those attributes. For example, let's say if there is a phone number, only integer is possible. That is a constraint, right? If it is name, the string values can be possible. Likewise, you can have constraints for the columns, right? And we have two other things. In order to connect one table with another table, what we are usually used in a database, in relational database, how do you connect or how do you join two tables in order to process your query? How can you connect two tables?
From relation IDs.
Yeah, exactly. Relational IDs in the sense we have primary keys and foreign keys. Am I correct? So, what is a primary key then? Usually, if there is a student table, these IDs are the primary key which we use to uniquely identify each rows. Then what is a foreign key? If you see here, if you use this student ID to connect this class, and if you have used this class ID, then that is a foreign key, right? For example, if there is an employee ID and you have a department table, and if this employee table and department tables are connected through the employee ID, and if we store that employee ID in the department table, then that's the foreign key. In order to make a relationship between two classes, we are using these foreign keys, right? That's how the columns were connected. That's how the tables are connected. All right, that's basic about the relational table. All right. What are the advantages or what are the characteristics of relational databases? Like I already mentioned, the relational database tables are well structured and they have a defined schema, right? That's the basic thing. When it comes to relational database, you cannot have a relational database which where you can accommodate any type of data, right? If there is a user, there are attributes. You can store only the values to those attributes. All right, that is what the structured data model means. And incorporated with many well developed technologies. Okay, for example, when it comes to a relational databases, there are so many technologies that relational database management systems have, many supported technologies. For example, you can have an index, you have a optimizer to do a query optimization, and the physical organization of data is well structured. So you have a well developed technologies to support the relational data model, right? Okay, are you aware about indexing? Did you ever come across with the term indexing?
Yes.
Okay, what is indexing? Oh, why we need
Uh,
indexing?
we need then large data in the table. When you search queries, we indexing that then easy to search.
Yeah, easy to search. Easy to search in the sense of with minimum time, less time you can search the needed record and you can get it. You can say with the minimum disk block access, right? So all these can be supported by a relational database. Already you have a relational database management system. They have the power to create indexes. There are optimizers to optimize your query to give the results as soon as possible. So those are some advantages we are having when we are using a SQL database. Strong concurrency control protocols, right? There is something called ACID. If you are using a relational database and if you are trying to do some transaction on those relational databases, right? What do you mean by transaction? For example, if you perform some read or write operation on your database table, if you try to read the user details, or if you try to update the user detail, update the first name or update the last name. So if you are trying to do some transaction in the database tables, the transaction should follow ACID properties, right? ACID means A stand for atomicity, C stand for consistency, I isolation, and durability. All right. So what is this atomicity, consistency, isolation, and durability? So atomicity means, for example, if you have a transaction, for example, let's say you are transferring an amount of 5,000 from an account A to B, right? In that case, let's assume there is an account A, and you are transferring sum of money like 5,000 to A to B, right? So what are the operations that need to be performed in that particular transaction? What do you think? In your bank account, if somebody wants to transfer 5,000 from an account A to B, what are the operations that need to be performed inside that one? First, you need to read the balance of your account, right? And then you need to deduct 5,000 from your account and deposit that 5,000 to B account. That means this B account's value, the balance should be updated by increasing the 5,000. A's balance should be decreased by 5,000. So all these operations need to be performed with this single transaction. You are transferring 5,000 from A to B, a single transaction. But inside that single transaction, there are multiple operations need to be performed. All right. So if one of these operation is not performed correctly, or one of the operation is stopped in the middle, then you have to roll back. Roll back means you have to abort the entire transaction and you have to go to the previous state. You cannot have any partial transactions. For example, can you deduct 5,000 from A and without depositing into B, can you close your transaction? No, we can't do it. So there is no any partial transactions possible. All right. That's what we mean by atomicity. All right. Then consistency. Consistency means if you have a database state, let's assume you have a valid database state, and the data, each of the values in your database should be moved from a consistent state to another consistent state, right? For example, in the beginning, if you have 5,000 in your account and you don't do any transaction related to that 5,000, then at the end of the transaction as well, you need to have 5,000 in your account. That's what we are moving from a valid state to another valid state. All right. And the next one is isolation. Isolation means if there is multiple transaction access the same database, right? And both of the transaction, even though they executed concurrently, it should not interfere with each other. That means in the middle of a transaction, you cannot see the results of another executed transaction. That is what isolation means. So both of the transaction appear to be executed isolately. And then the durability means if there is any fail, once the transaction is committed. What is committed? Did you ever study about transaction earlier? In database management systems? Do you know the word commit, abort? No? Alright, it's fine. Commit means you are permanently storing your data value to the database. That's what commit means. So once the transaction is committed, that means your updated value is permanently stored to the database. Then later, even if there is a system failure, your data cannot be raised. That is durability. All right. So when it comes to a relational database, if you perform some transaction in the relational database, the relational database management system makes sure the transactions have ACID properties. It will follow all these four properties. Did you understand what do you mean by ACID properties and how it works? Do you have any questions? No? Okay.
No.
All right. Okay. Then we'll move on to the next one. Okay, so in that case, shall we do a quick activity? Otherwise, since it's an online lectures, it might be boring if I am talking always and you are like hearing it, it will be boring. So shall we do a quick activity? Can you just think about this scenario, right? Let's say there is a customer, Alice. He want to transfer a sum of LKR 10,000 from her saving account to her credit card account or to her credit card in order to pay the credit card money. Okay, so can you consider this scenario and explain asset properties? Explain in terms of try to figure out, okay, how asset property works if this particular transaction is happening. Just take a piece of paper and write. Then let's discuss. I'll give you 10 minutes or 5 minutes. You can quickly do this activity. Then we can discuss this activity. I hope you all understand the question, right? So this is the scenario and use this scenario and explain each properties, how atomicity, what is atomicity using this example, and consistency, isolation and durability. Okay, let's do it together, right? Okay, first, what do you think? The first property, atomicity.
Yeah, in the atomicity, that transaction cannot be partially. It should deduct from Alice account and savings account, and its credit should be uh, credit should be a credit card account.
Excellent. Yeah. So when it comes to atomicity, like you said, it should be debited from Ally's savings account and the money should be credited to Ally's credit card account. There should not be, if in the middle, let's say, once you're trying to credit it to her credit card account, if there is any system crashes happen and if it stop in the middle, then entire transaction need to be rolled back. Roll back in the sense it have to go to the previous state, the initial state, before the transferring process starts, right? That is atomicity. All right, the next one, consistency. So when
Same,
it comes, yeah, go ahead.
same amount should be uh, debit and credit in the both account.
Yeah, that's correct. That's also one way of showing the consistency. The amount that is deducted from Ally's account should be deposited to her credit card account. So we can say that at the end, the sum of money in saving accounts and credit card account should be equal, right? So for example, before transaction, if it is 50,000 plus 5,000, 55,000. After transaction also, 10,000 should be deducted from here and 10,000 should be added to here and the total should be 55,000, right? That's what consistency means. It's starting from a consistent state and going back to another consistent state. All right. Okay. The next one, isolation.
Any other transaction should not be effect to this transaction.
Yes, exactly. So if there is another transaction, let's say another person or another user Bob transfer another 20,000 to maybe to Ally's account, but that should not be interfere with this Ally's transferring process. That is what isolation means. Finally, the durability.
After committed system crashes, even system crashes, the data cannot be lost.
Exactly. So after committed, once Ally's finished her transaction and committed it, so Ally's saving accounts will have 40,000 and let's assume credit card have 15,000. So at that point, when there's a system crash and when you're trying to restart the computer again, and again the saving money should be 40,000 and credit card balance should be 15,000. So this is what atomicity means. So if you are using a relational database management system, you don't need to worry about any of these things. Its relational database management system's job is to handle all these properties and that will make sure your transaction will follow all these four properties, right? So that will increase the data integrity of your system, right? That is about strong concurrency control mechanisms and ACID properties were there for relational database. The next one is normalized data. I'm pretty sure you heard about the term normalization, right? Normalization means you can divide the data and split the data and store them into different table in order to eliminate the data redundancy, right? So that is normalization means you might study about first normalized form, second normalized form, third normalized form, right? Did you all started to study database management system? Do you have database management system in your curriculum?
Not yet found. Need to check in the future.
Maybe in second year, maybe. All right, though, all right, maybe, but you might be aware about this in your undergraduate or something, right? Anyway, I'll tell you, normalization means we have to, for example, rather than have all the data in a single table, right? For example, you might have user data. You might need to store the information about the user. When it comes to user, you might able to store their addresses as well, but address can be have subfield, right? One address can be have number, house number, and then street name, city name, division name. Likewise, within a single address attribute, there can be subfields. So rather than having it everything in a single column, a single table, you can separate them into a multiple table. Have the user details in one separate table, address details in another separate table, and you can use foreign keys to join them, right? So that is what normalization means. So in order to omit some inconsistencies and data redundancies, we are normalizing the database, right? So that is the next characteristics of a relational database. And the fifth and final one is well-established system, right? Relational database, we are using it for such a long time. So if you want to implement a relational database management system, you have high community support. High community support in terms of there are several documentations available, there are resources available to build it. If you found any issues, there are platform to clear out your issues. So there is a well established community or ecosystem available for these relational database systems. All right. So these are some main characteristics of the relational database systems. Okay. Okay. So we said, okay, we have all these characteristics. Then what makes us move from a relational database management system to a NoSQL database system? That's a big question mark. We have all these advantages, right? We have a predefined schema, we have a ACID compliance, we have a well established ecosystem to support our implementation. Even though sometimes for some application we might need to move from these relational databases to other database models, right? The reasons are there are some limitations in relational database management systems or relational databases. We'll see one by one. These are the reasons that initiates the origin of another alternative data model, which we called as NoSQL data model. All right. Okay. What are the limitations? Let's see one by one. First one is static schema, right? Static schema means, as I mentioned earlier, it has a rigid schema. That means predefined and well-structured schema. Sometimes it's an advantage. So since you have well-structured schema, there will be no much inconsistencies possible, right? Because you know, okay, these details can only be accepted by the database. Some values cannot be accepted. It will be give an error message for you. But sometimes it is not suitable. Why? Why do you think? Why do you think it's not suitable in some places? Let's take an example. Let's say if you want to creating a chatting app, right? Where you can have a community and you can chat with the people and people can create, take an example, Facebook, right? You can create your post and you can tag people, people can comment on it, right? Likewise, if you have such a application, the number of data that we have is very high, right? The volume of data we have is numerous users can be there. They can create different types of post. One post will be different from other post. If there are chatting platform, the two persons are try to chat through that chatting platform. One person chat content will be much different from other person chatting content. So the in the real world, the actual data, they don't have a proper structure, right? Time to time, the structure of data might change for based on each user. So in order to accommodate that unstructured nature of data and high volume of data, you need to have a alternative data model other than this relational database model, which have a flexible database structure. Are you agree with this? You might come across with those things, right? If you have a static schema where you have to predefine the attributes, where you have to tell, okay, what are the attributes, values could be possible. But in the middle, if there is a new column need to be added, or if new attribute need to be added, it is bit difficult in relational database. But based on the need, the current need of the system, we need to have such alternative data. So that's why static schema is one of the issue in relational databases. The next issue is performance overhead. Why this performance overhead come? Because these relational databases are too strict in terms of we have to normalize the data. You have to have transaction which follow these ACID properties, right? So each time there is a read or each time there's a write, all these constraints need to be checked in order to update a database or in order to allow the, for example, let's say each time when you try to read something, if it is have to go through, so if the table is for example, if the if your database table is divided into multiple tables, and if you need to read something from all these tables, you have to perform a complex join operation, and we have to retrieve the data. So for each write or read, you have to perform a lot of work, which will decrease the performance of your query processing, right? That's the next issue. Because usually in the real life, day-to-day life, each application might have so many frequent updates time to time. So when you have a relational database management system, it should go through all these normalization and ACID property checks in order to approve a transaction, right? So in that case, it will reduce the performance. The time, there will be a high latency in terms of the time taken to get your results will be high. Then your performance will be less, right? That's the next issue. The next, another one is high cost of ownership. Most of the commercial relational database management systems are very expensive in terms of their license. You have to pay so much. And for maintaining its infrastructure, to hire staffs for that, it will cost a lot. That's the next reason we are moving to an alternative form which should have some less cost, right? So these are some limitation, and the other limitations were impedance mismatch. All right. So this is the one of the most important issues with the relational databases, right? You all know you have we used to have a programming languages where we are trying to write our backend code, right? And you have your relational databases. Relational databases and programming languages need to be combined in order to develop a system. Am I correct? So you have to have a database and you need to write your system or your backend and front end using programming language, and both need to be worked together in order to carry out the jobs inside the system. All right. What do you think the data structures that you are using in a programming languages? Do you know what is data structures? Are you familiar with data structures? Different types of data structure, for example, arrays, list, dictionaries. Am I audible to you?
Yes, ma'am.
Okay. In the middle of the lecture, if I am not audible to you or the slides are not changing, please let me know. All right. Okay.
Okay.
When it comes to a programming, for example, let's say you have your programming language, right? And you have a database, right? We have to store the data inside the database and we have to access the database and the system works. All right. In programming languages like Python, Java, whatever the language that you are using, they have complex data structure. We can have list, we can have objects. If there is an object oriented program language you are using, for example Java, you can create objects inside your coding, and you can have arrays, list, stack. Different types of data structures could be possible. We call them as in memory data structures, right? But in your relational database, right, in your relational database, we cannot store such data. Naturally we cannot store such data. Can you store a object inside your relational database? Can we store a nested array inside the database? That is not possible, right? We have a flat tabular structure inside our relational database. So the data structure in the supported by programming language is different from the data structure that is supported by the relational databases. That is what we called as impedance mismatch. Did you all understand what is impedance mismatch means? Any issues up to now?
No.
All right, so we have a different data structure. We have a complex data structure inside our programming language, but we have a more flattened, more tabular like structures in our database. Because of this dissimilarity between these two structure, we called it as impedance mismatch, right? So in order to in order to store some data here, or in order to access some data from the database, you need to do some mapping here, right? We have to map the data structure, right? That is time consuming. Each time when you are trying to store some data, we have to have some mapping here. That is the one of the issue when it comes to this impedance mismatch. All right, let's see. Maybe if we have an example, you might better. Okay, if you take this example, right? If you consider this example, let's assume in your programming language, in your code, in your backend code using Java or something, you can able to store this nested data, right? You can write a code to store the nested data. For example, ID, customer name, customer orders, and his card details. So we can write code inside our programming language to store this nested data. But when you are trying to store these data inside your relational table, you cannot do it within a single table, right? For orders, you have to have a separate table. For customers, you have to have a customer table. For card, you have to have a card table. In order to store a single nested data, you might need to store them in different tables. So in future, if you want to access the detail of Kamal, or details of a person with employee ID 001 with all his order details and card details, you have to access and join three tables together, and you have to perform that complex join operation in order to retrieve the data, right? Which will reduce the performance of your system, right? So that is the reason, if there is an mismatch, we need to do a tedious mapping process. Even though there are some models to handle this mapping process, again the join operations will reduce the performance of the system, right? So if you remember, I said that mapping need to be done, right? From programming language data structure to the database data structure, we need to do a mapping. So for the mapping, currently we have something called object relational mapping frameworks. For example, Hibernate, right? These mapping frameworks can use to automate this mapping process. You don't need to manually do that mapping. So it can be automated. Even though it is automated or even though it is manually done, again, the performance issues will be there in terms of joining the tables and getting the details. the performance issues would be there. All right, that's the issue with the impedance mismatch. The next one is scalability and availability issues, right? What do you mean by scalability? What do you mean by scaling a system? Usually, scaling the system means we are increasing the power, right? That's what usually we meant by it, right? For example, you can increase the power storage of a server. You can increase the power of the hardware of the server. That is one way of scaling the system, right? But let's think about the, like as I mentioned earlier, the volume of data increase so much these days, right? If you are taking an example of a Facebook or any social media platform, think about how much data is generated for each second, right? So the volume of data generated is very large, right? So in that case, you need to have a more computing power to, or computing resources to store that much amount of data. So one thing you can do is we can increase the storage capacity of one single database server. Or else what we can do? What do you think? One way possible is to, you have a database management system. You can increase the storage capacity of that particular server. What else we can do? What do you think? What about having multiple servers? What about having multiple storage servers? That is another way, right? So when it comes to relational databases, that is not possible, right? Having multiple storage nodes, which is not possible. So usually, since we have a single server, and if you're trying to increase the storage, at one point it becomes so expensive and you cannot increase more. The scalability is limited. Another issue is if you have one server, there is a probability of single point of failure, right? What is single point of failure?
If one fails, whole system fails.
Yeah, exactly. So when there is a centralized database like relational database management system, if you have only one server, if that server fails, you cannot access your data anymore, right? So that is single point of failure issue also there. So when it comes to scalability, that means in order to store large amount of data, there is an issue. When it comes to availability, that means if there is only one single node and if it is failed, your system is no longer available, right? So those two issues are there when it comes to a relational database management system, right? So in that case, we have to have some alternative data model which support horizontal scalability as well, right? There are two types of scalability. One is vertical scalability and another one is horizontal scalability. Vertical scalability means we have only one server. We can improve the capacity of the server. But we have already discussed there are issues with that. At one point, we cannot scale more. It was very expensive and single point of failure were there. Then next option is to have add more servers to it and have data in each servers, right? So even though one server fails, other servers can handle the remaining request. So it will decrease the single point of failure and it will reduce. You don't need to have a much large expensive storage capacity unit since you can add multiple servers one by one, right? So that is horizontal scaling. But when it comes to relational database, this horizontal scaling is not natively supported, right? That's another issue. All right. So these are some issues related to relational database. So as we discussed, so first issue is static schema, right? So dynamic nature is not there. And the second issue is we have discussed that performance issues related to write and read. Then impedance mismatch and cost of ownership. And then we have discussed about scalability and availability challenges. So even though there are some advantages of relational database, there are some disadvantages or limitations as well. That makes us move from SQL to a NoSQL databases. In order to address those challenges, in order to address those limitations, we are moving from this SQL, I mean the relational database, as to a NoSQL databases, right? Because the current trends are the volume of data is high and the velocity of data is high. Velocity means in frequent update in each data, and big user, the number of user is very high. So the read from those users are very high, and variety of data, we have so many unstructured, semi structured data. So these are the current trends. In order to manage these current trends, we need these requirements. We need to have a database which is scalable. We need to have a data model which is flexible. We need to have a data model which support read and write frequently. So that's where we are moving from the SQL to NoSQL. All right. Are we clear up to this point? The need for a NoSQL database, did you understand? Why, even though we have SQL, even though that was well supported and there are advantages, because of the current requirement, current trend, we are moving from, because of this big data culture, we are moving from the SQL database to NoSQL databases. Even though there are some database applications, still they rely on these type of relational database because they need the structured data. They might need to have this ACID property support, and they need high security, right? That are the main reason. There are still some application that depends on SQL databases. All right. Do you have any questions up to now?
No.
If you
No.
All right. So let's move on to NoSQL database. So now you understood, okay, why we need this NoSQL. Let's see what is a NoSQL. NoSQL means not only SQL or any databases that are not a relational database, we call them as NoSQL. You have relational database. We have studied about that. We have limitation. Then we come up with NoSQL. So NoSQL is any database that is not a relational database, then that is a NoSQL database. All right. Usually, NoSQL databases have these common characteristics. They are not using SQL languages, right? They are not using SQL to process the query, or they are not using relational model, right? They are not using that tabular fixed structure, right? They are distributed in nature. Distributed in nature means we'll study it later, but for now, for an understanding, you can split the database and store them in different places or different servers, right? That is distributed in nature and designed to run on large clusters. That means your database can, like I said, distributed, and they can run on different clusters. That means different nodes, and they don't have a, you can say no schema, or you can say flexible schema, whatever, it's okay. And most of them are open source, right? You don't need to spend much money for their licensing. Many NoSQL databases are open source. So these are some common characteristics for a NoSQL databases, right? So anything which is not SQL or which is not relational database, we call them as NoSQL databases, right? So we have studied about some common characteristics. So let's figure them out in a more deeper way, right? First one, flexible modeling, right? Flexible data modeling in terms of, did you remember we have studied about impedance mismatch? So what is an impedance mismatch? We just studied about impedance mismatch, right? What is that? If there is a programming language data structure, their in-memory data structure are different from our relational database models, right? That is impedance mismatch. Did you remember?
Yes.
All right.
Yes, ma'am.
Yes.
Yeah, that is impedance mismatch. So this impedance mismatch is because of we are having a relational database model which this only tabular format, only with these tables. So we need to have a alternative data model or alternative database which might support different types of data, right? If you have unstructured data, it can be able to support. If you have a semi-structured data, it can be able to support rather than only supporting the structured data, right? So in NoSQL database, there are 4 different types of NoSQL databases are there. Document databases, key value databases, and column family databases and graph databases. There are 4 databases, 4 types of databases are available, each with different types of structure, each with different types of use cases. So since we have different types of database models and different types of NoSQL databases, each one can support the particular job. For example, if you want to store some unstructured data or a semi-structured data as a document, you can go for a document database. If you want to store different types of users and if you want to show that relationship between those users, we can go for a graph database, right? Each of these databases, we'll study them in the upcoming slide in depth. But for now, you can see flexible data modeling means since we have different types of databases, different types of data can be stored in those databases, right? That is first one, flexible data modeling. Then the next one is high scalability, right? High scalability means if, like I said, there are two scalabilities both can be possible. One is horizontal and another one is vertical, right? Vertical means you have a you can increase the power of one node, or you can have multiple nodes, right? You can add one server, another server, another server, because the distributed nature of the NoSQL, that means you can split them in, store them in different nodes. You can easily handle the scalability issues, right? We can have several nodes and you can store your database in those nodes and you can process, right? That is the next thing. It will support the horizontal scalability. And the next one is high availability. High availability means NoSQL assure 100% database uptime. That means single point of failure is very less. Why is that? What do you think? Why there is no single point of failure?
Due to horizontal yeah,
Yeah, horizontal scalability. Yeah, that's one of the reason because we can store data in different nodes, right? And even though one nodes fail, the other nodes can work, right? So there is two things, right? One is sharding and another one is replication in NoSQL database, right? Two different things. Sharding means, let's say you have 10 tables, and if you divide the tables, like one table, two tables in one node, another three tables in another node, and another four tables in another node. If you store like that, we call them as sharding, right? You split your database and store them in different nodes. Another one way is you can have entire copy of your database in each node, right? Both things can be possible. For example, let's assume there is A, B, and C, right? One thing you can do is you can store A here, B here, and C here. That is one way. Sharding could be possible. Or else you can keep this ABC in this node, ABC in this node, and ABC in this node. Both can be possible. So if you take a copy of ABC and stored in all three nodes, we call them as replication, right? So if you completely replicate your data, then that means you have a high availability, because even though one node fail, you have another two node which have all your data to support the availability criteria. Even though there is ABC, what do you think? Will it create a single point of failure? You have divided ABC and store them in different nodes. You go for a sharding approach. Will it be a single point of failure?
Not single point of failure, but data, some table can be lost in that model, right?
Yeah, exactly. So let's say this C fails. So you cannot access the data from C. Still, the user who wants to access A and B, they can access it. So partially you are giving kind of availability. But if you have a full replication, you have a higher availability, right? But still, if you have a full replication, there are disadvantages as well. But okay, we don't need that for our curriculum. We'll move ahead. So that's based on our requirement. You can go for a full replication, or a partial replication would be okay. Anyway, both of them will not go for a single point of failure. All right. So that's way, in that way we can have a high availability. All right. And then next one is polyglot persister. This is another important thing in the NoSQL database. For example, let's say you are creating a system, right, which consists of different use cases. For example, that particular let's say you are creating an e-commerce platform. That e-commerce platform have a functionality to maintain the shopping cart, and a functionality to maintain the orders and maintain the inventories in the companies, and in order to provide some recommendation for customers, you have a customer social graph, right? You might have different requirement even for a single system, right? But based on the requirement and based on the nature of the data that you are going to store on those requirement, you can choose different types of databases, because we have four different types of databases when it comes to NoSQL. So based on your requirement, you can pick the needed one and you can use it for that. That is what polyglot persistency means, right? Many database storage technologies can use for the suitable data requirement even within a single system, right? That is the next advantage of this NoSQL databases, right? Okay. So, like I said, we have this distributed nature of NoSQL database. That means you can store your databases in different nodes and different people can access it. So if you take this example, uh, for example, take an example, there's a company, right? The company have a manufacturing unit and a sales unit, and they have a head office as well. Let's assume there's an ABC company, and ABC company's headquarters in Colombo. They have their manufacturing unit in Gold. They have their sales department or sales unit in Kandy, right? So in three different locations, they have their physical stores. All right. In that case, you can store only the needed details in the each location rather than have everything in all location, right? For example, let's say you can have a node with the database which have the data related to manufacturing in that particular location. And you have a database for sales department, and that database will consist of only the needed details regarding sales. Headquarters, maybe headquarters can access all the details. Likewise, based on your requirement, you can structure your databases, right? Even though your companies having their physical units in different locations, in those local location you can store your database which has only the needed data. You don't need to store everything. Do we need to store sales related data in the manufacturing unit? We don't need. Do we need to store the manufacturing related details in a sales place? We don't need that details. So we can split the details and store them in the needed places. In this way, we can reduce the data traffic. How can you reduce the data traffic? What do you think? How this distributed nature can reduce the data load or data traffic compared to a centralized database? Mm-hmm. Let's say there's a centralized database, right? Everybody will access that particular centralized database. We have a headquarter, manufacturing unit, and sales. One single centralized database will be accessed by all three units. So think about how many requests will be coming to that particular database in a single time at the same time. But if you divide this data, only this manufacturing people, they will send the request here. Sales people send the request here. Headquarters people send the request here. So you can manage the data load. What do you think? You can reduce the number of requests toward a single database. In that way, you can increase your performance as well. Did you understand? So that is the advantage of one of the advantage of having this distributed nature, right? But if you have this distributed nature, will it be behind? What do you think? Did you find any issues with this distributed nature?
Yes. How about the relation with those data?
A relation in terms of
The headquarters access that table. If headquarters needs to get sales data or manufacturing data, how it?
yeah. Yeah, there will be a distributed database management system, right? Usually in relational database, you have relational database management system, no? Likewise, in distributed databases, we have something called distributed database management systems. So if headquarter wants to access some manufacturing data or sales data, it will send a request to that distributed database management system, and it have all these fragmentation details and these location details. So this distributed management system, no, okay, headquarters need some manufacturing data. Then it will redirect that request to this particular manufacturing related database and get the results from that and send it to the headquarters. Right? That's how this distributed databases work. But that is not a big issue. Other than that, what do you think? Let's assume, like I said, okay, when it comes to a database, sorry, okay, see here, you have A, 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 right? We have a complete replication, right? You assume we have a complete replication. You have stored the table A in all three nodes. Let's assume there is somebody X updated this A value, right? And at the same time, if Y try to read this value, what will happen? For Y, will he get the latest value immediately?
No.
A is no, that is the issue, right? So when there is an updated by X, it will be updated here. It will take some time to propagate that update to this node. Before making this update, if Y reads it, then it will read a stale value. That means not updated value. That's the one of the issue with this distributed databases. If you have a full replication, right? So that's why usually almost all the database distributed system, maybe it's a database or whatever system, it will follow something called cap theorem, right? That means at the same time, you can provide only two of these features, right? Let's assume if there are three properties, consistency, availability, and partition tolerance. If there is a distributed system or distributed database, in the same time, it can give you only two out of three features. You cannot give all the three features to it, right? We'll see one by one. Cap means, C means consistency, A availability, P partition tolerance. Okay. Consistency means each time when when a reader or when a person reads the value or trying to read some data, he or she needs to get the reason right, or they need to get an error message. Okay, let's try to explain it using a table, then it will be easy for you. Okay. Okay, so you have distributed database with three nodes. A is stored in each node. So if X updated it and Y tried to read it before this X updates propagated to this node, then this node should give an error message to Y. If you have 100% consistency, that means let's say A's value is 100 once after the update, A value is 100 here. But initially, let's assume A's value is 90, right? Until the new update propagated to this node, if Y try to read it, it should give an error message. It should only get the most recent right. Updated value should only be given to Y. That is consistency, right? Availability means every request, right? Every request should get a non-error response. So if Y is trying to read the data, it should give a record which is it should give a result which is not an error message, right? It might contain most recent read, or it might contain most recent write, or it might contain some stale data, that means not updated ones. That is availability. Partition tolerance means, let's assume if one node is failed, or if few nodes are disconnected, even though it is disconnected, the system should work even with the disconnected nodes. Let's say if these two nodes were disconnected, this node and these two clusters should be work independently. That is partition tolerance. So if you are creating a distributed system, you cannot have everything, right? So you can have consistency and availability, and partition and tolerance would not be there. Or else you can have partition and tolerance and availability, consistency should not be there. Likewise, based on the requirement, you can provide only two out of these three attributes. That's how usually most of the distributed uh, systems work. All right. Did you understand? Do you have any questions?
No.
All right. But when it comes to NoSQL database, our main aim is to provide flexibility, right? So in order to provide flexibility, NoSQL support a model which we called as base, right? Do you remember in relational database we have studied relational database support ACID, right? That means it should have a high consistency. That means relational database need a immediate consistency. But when it comes to NoSQL database, it supports something called base model, right? What does this base means? Basic availability, soft state, and eventual consistency, right? So it support base model in the sense for NoSQL, it is okay to have an eventual consistency. That means even though if the latest update is not propagated to the new node, it allows the reader to read the stale value, right? It support this eventual consistency where later, so after sometimes the nodes can become consistent. So we don't need it. We don't need that to be done immediately, like in relational databases. All right. Okay. You will better understand if you go to the next slide, I guess. Okay. Right. So base model BA means basically available, soft state, and eventual consistency. Let's take an example. Right. The similar example we discussed in the last slide. Let's try to understand what is eventual consistency. Okay. Let's assume this A is updated. A data value A is updated by a user X, right? And the X user still continue with his operations. He's still continuing his transactions, right? In the meantime, Y is trying to access A, right? We are not going to stop Y. We allow Y to read it, but it will not read the most recent update. It will read the initial value, right? And later, once all these transactions are finished, then we will propagate this value to A. Propagate means we will propagate this update to this node and propagate this update to this node as well, right? Immediately you don't need to propagate it. You can have some time and later once all the transactions are finished, you can send it, right? Which will improve the availability of your database, right? That means for your system from when outside user when they are trying to access, for them it seems like, okay, always you can able to access your database. There is no any error messages. When white try to read it, you are going to show them the details even though there is no consistency, right? So that is what basically available means. Always the system will available. And soft state means in the meantime, between these update propagation period, you allow your system to be in a state which is flexible. That means in that state, your system might have some inconsistencies. That is soft state. And then eventual consistency means after some time when X complete all this transaction, the update might be propagated to A. That is base model. So when it comes to NoSQL, that will support this base model. But relational database, which will not allow this base model. What do you think? Can we able to use this base model for any of the systems? Is it allowed or is it accepted to use this type of base model for any applications?
If the application is complicated, ma'am.
Complicated in terms of, for example, use case actually. For example, let's say if there is a banking system or any system that is to do with some financial things, can you have this eventual consistency? For example, let's say you have let's say you have 10,000 in your bank account, and you are in a process of like withdrawing that 10,000, and meantime somebody wants to take another 5,000. You have to deposit another 5,000 to an account. Would it be possible? Like, because of eventual consistency, you are trying to withdrawing it, and you don't have money on your account anymore, but in the meantime you are trying to deposit to another account. So for this financial account which need high consistency, this base model is not that suitable, right? But for other application, for some e-commerce systems, for example, you are going to view your previous orders, view your past history, or you are going to view some data, even though it is not updated, that's okay. For those type of data, this maze model is completely fine. You need to view your past ordering history. Even the last history is not updated. Will it be a big issue?
But in e-commerce system, if we think we are going to order something, there's only one item. But
Mhm.
in that case, that also not suitable this model, right?
Yeah, that's why you might experience it with it. You might try to add the stuffs to the card, right? In your usually some e-commerce
Yeah.
system, if you try to add something to the card, but when you are checking out, it will say out of stock.
Okay.
That is the issue, because since if they are following a base model, somebody, you are in a process of reading it, reading, okay, let's say there's a t-shirt, it will show available, but there will be only one stock, and there's another person also accessing it. So when he check out first before your one, only at the checkout point it will show you out of stock. So you might face these issues when you are trying to order something, right? That's all because of this eventual consistency. Do you come across with those things? After sometimes it will say out of stock. When you try to check out, it will say, oh, this product that you have selected, it's out of stock. At the point only in the checkout, that consistency might come and it will give you a error message. Did you come across with those things anytime in your life?
Yeah.
Yeah. So that issues, but will it be, did you make a big issue with that one? Okay, if they said out of stock, you go and book
Yeah.
another product, right? So, but when it comes to financial things, that's not the case. It's a big issue. If we are trying to, if your account is already in zero balance, and if they accept you to transfer another 5,000 from a zero balance account, that's an issue, right? So that's why still some financial system, they are rely on these relational databases compared to these NoSQL databases, right? So that's it about this base eventual consistency. So these are the characteristics of a NoSQL databases. They have a flexible data model, they have a high scalability, they have high availability, they have polyglot persistence to support numerous amount of requirements, they have eventual consistency to improve the availability. So all these different features, if you see all these features, most of them are for the flexibility. Most of them are to support the big data requirement of these days, right? So that is why those are the main characteristics of NoSQL, right? And when it comes to flexible modeling, I told you there are four major categories of NoSQL databases. We will quickly go through one by one, right? What are the four different types of NoSQL database models? First one is key value stores, right? Key value stores mean, okay, there are four key value store: column family, document database, and graph database. Based on, based on our use case and based on your requirement, you can choose whatever you want, right? Let's start with key value stores, right? Key value store means, this is one of the example for a key value store. Usually you have a key. You can think this as a primary key. And for that key, you will store the values of different data. That is, key value means there's a key, And for the key, the associated values will be stored. For example, customer data. You have a customer ID and the customer data will be stored, right? The difference here is this customer data can be any type. That could be a scalar value, that could be a hash table, that could be a list, that could be a sorted set, anything. This value can be any type of data structures. So there comes that flexibility, right? You don't need to have a, okay, you don't need to predefined that, you don't need to mention that, okay, these are the data we are going to accept. You don't need. You can have list of data, you can have a table as a value, anything is possible. That is key value data store. You have a key, and for key, the related value will be stored. The value can be anything, a string or a list or sets, anything could be possible, right? So if you want to find the details since it's a key, if you want to find the details regarding a customer with the customer ID 1, then you can check an equality condition with the key. You can check for the keys and you can find the key with the customer ID 1 and you can find your details, right? So using the exact match on the key, you can retrieve the data. Usually we are using this type of key value data stores to store the session informations, right? Key value databases, we are used to store the session information. You know what is sessions, right? So when you log into a system, a session ID will be created for you, and based on the session ID or your logs, what are the things that you are done inside the system will be recorded, right? So in order to store those session details, usually this key value model will be used, right? So you will be given with a unique session ID, that's your key, and the values, that means all the activities and all the updates that you make inside the session will be stored as a value. It can be stored as a string, it can be stored as a table, or it could be stored as a list, right? So that is what key value store means, right? So when it comes to example, these are some example for key value store. React, Redis, Oracle, these databases follow this key value store model, right? That's about key value store. And the next one is,
Excuse me.
yes,
Oracle is a relation database, right?
there is a key value store database for Oracle as well. There's
Okay.
a key value store.
Okay.
Okay. And React and Redis is there. Okay. The next one is document. It's a well-known model. You might also know it. MongoDB, right? Mint or Mongo will be documents. The key will be there and document all the related details related to customer. So do you recall the example which I told you earlier? When you want to store a customer detail, customer ID, customer name and their address, if you want to store them in a relational database, you have to store them in separate table, right? Customer detail, customer table, and billing in order to store the address, you might need another table. So you have to have a join in order to get all the details. But with this document, you can keep them everything together in a one single document, right? So usually these documents can be implemented using XML or JSON or BSON objects, right? When it comes to MongoDB, as far as I remember, it's BSON. BSON are used to implement these documents, right? So when it comes to documents, there can be a collection of documents, right? If there is a customer, all the customer documents, we call them as collection, right? So they are similar in nature. Everything is a customer details, but they have a different schema. For one customer, you might store their address details. For one customer, you might store their bank details. Another one, you might not store their bank details. Likewise, they have different information, but everything is the customer details. So the collection of the collection of this customer document, we called it as collection. So inside a collection, the documents are similar, but with different schema. All right. When it comes to especially in MongoDB, you can create search indexes as well. MongoDB support search indexes, and we can do a query search using indexes as well. All right. So if you take this one, this is a part of code that you can write using a MongoDB. And if you see that, you can store whatever data you can, right? You can store scalar data. Scalar value means each single value we call them as scalar value. Or else you can store nested document. If you see here, if there is a order which have order ID, total amount, and within the total amount you can have items with product ID. So it's a nested document. Within an order there is another subset, product. So you can have this nested document, and you can have boolean values. For example, if you see this is subscribed, if he is subscribed to a loyalty point, so if not, then boolean values can be stored. So you can able to store different types of data inside a single document, right? Like I said, logical grouping of these documents, we call them as collections. All right. So that is about document database. Usually when you are implementing a chatting application, then within a chat, let's say if two-person chatting and other two set of person chatting, the content of both chats are different. So for those type of use cases, we can go for a document-based databases. Or if you want to store the event details in an application, if you want to store the event details, each event might have different data need to be stored. So for those event details storage, you can go for a document database, MongoDB, right? So that's about these document databases. Do you have any question with the document database? Any questions?
No.
All right. Okay, the third one is column family, right? Column family is pretty much similar to your relational database. The difference is here the columns can be created on the run. On the run means you don't need to have a predefined, okay, these are the columns that should be added. You don't need to have that predefined column names. On the go, you can add columns, right? And the next one is you can create sets of column. For example, let's say if you usually the first name and last name are accessing together, right? If you are accessing if you are creating a profile for a customer, and in the front end, if first name is loaded, usually the last name should also be loaded together. So for the columns that are accessing together frequently, you can create a family of columns, right? And store them in a separate space, right? Another one is usually when you are getting your user details, the profile picture also will be seen in the applications, right? So the picture can also be a part of column family. But the other details, for example, the order details, that could be in a separate column family. Likewise, you can have a vertical separation of column and keep them in separate places, right? So that is about column family. So only the columns that accessing together, you can make them as a family and store them together. For example, Cassandra database work according to this column family data model. So if you see this one, if you, for example, you might need all the profile informations, name, billing address, payment details. All these details can be stored as a single column family. And all the order details can be stored as another column family. Likewise, you can group them and store them in a needed place for frequent access. right? That is about column family databases. Usually, if you think about the use cases, let's say you are creating blocks, right? In the blocks, when you are creating some blocks in Medium, or when you are writing some blog in Instagram, sorry, not Instagram, LinkedIn, you might add hashtags, right? You can add hashtags, or you can add some keywords. So for a blog, you can store all these details together in a one column family space. For example, the tags and the column the block content can be included in one particular column family store, and you can store the other block details, the users of the blocks, or the people connection who read the blocks, those details in a separate column family. Likewise, you can segment them and keep them in a separate spaces for a easy access, right? That is about column family database models. And finally, the another famous NoSQL database, which is a graph database model, right? Do you know the example for graph database is Neo4j. Usually, most of the social media platforms that their databases are created based on these graph databases. Facebook, Instagram, any of these social media platforms are based on this graph database. The reason is, in social media platform, okay, what's the main thing? Why we need social media platform? To make connections, right? So in order to make connection, you need to suggest people, right? You know, in Facebook, you will get people you may know. How do you get people you may know? What do you think? How do you get these people you may know recommendation in Facebook? Based on,
According geographical locations and
yeah,
friends of friends.
yes, exactly. So based on the relationship between two, both of you, right? For example, if myself show as a people you may know to you, because sometimes you might have many mutual friends in UCSC, right? So in that case, they are making, or they are identifying the relationship between us, and they are identifying the patterns. Maybe if I was a friend of somebody and you also a friend of that particular person, they are identifying the patterns. They identify, okay, if I was interested in travel play, if I follow some similar groups which you follow, they identify those patterns and make the suggestions. So in order to identify these patterns, in order to identify this relationship, we are using this graph database where each person, each entity will be denoted by nodes, and the connection between them will be denoted as edges. For example, in Facebook, each user will be a node. The connection between them will be denoted in their edges. Even the node and edges, both of them will have properties. For example, let's say Facebook, if I am a person, let's say Madangi, and there's another person, let's say Amali. So Madangi, my details, starting from my school, the working place, the pages I like, all the details used to describe me will be stored over there in that particular node, and all the details related to Amali will be stored there in the particular node. So they will find a connection between us, the relationship between us. Okay, both of them are working for the same institute. Both of them are studied at the same institute. So these edges will be used to represent the relationship between them. And for that relationship also, there will be properties. Okay, how long they are working together, do they have some mutual connections. So based on these detail, they will identify the patterns, some interesting patterns, and they make some recommendations and suggestions, right? That's for example, let's say if I am friend with another person, and I that particular person like travel related stuff, then they might suggest travel related stuff to me, because they think, okay, since both of them are friends, this particular user might also like travel related suggestions, right? And you know, if you search something in internet, Later, the next day, you will get that as a recommendation, right? In Facebook, there will be advertisements. So all these based on your search history, the recommendations can be possible. So these things are handled through these graph databases. The example is Neo4j, right? Most of the social media platforms, they are work on these graph databases. If you want to analyze a relationship and find patterns, and if you want to suggest relationship, this is the best model, best database model, right? That is about the graph database model. So we have studied about four types of models, and we have studied about different use cases for those four types of models: key value, document, column family, and graph databases, right? So since we have these different types of models, since we have these different types of data models, based on your requirement, you can use it. You don't need to stick to a particular single data model, right? Even within a same app, even within a same system, you can have different data model. For chatting facility, MongoDB. If you create a social media post, you can go for social media platform which you need some recommendation, you can go for a SQL database, right? So within a system, based on the use case, based on the functionality, you can use different types of database models. How do you call it? There is a single term to call that one. Using different database models for different requirements inside a single system. How can we call that? We have studied just now, right? Polyglot persistence. Did you remember?
Yes, ma'am.
Yeah, all right. So that is about um, four different types of database models, right? So that's about NoSQL. So we have completed the part one of our lecture. So what is a NoSQL? So if I want to give you a summary, we have studied what is a relational database, advantage of relational database, and the limitation of relational database, and why we move from a relational database to a NoSQL database. Then we have studied about the characteristics of NoSQL database, and we have studied about four different types of NoSQL databases. Do you have any questions up to now? Anything that you want to clarify or any questions? Or else we can start the next section.
No question.
No question.
All right, okay. So next question is relational database security, right? We are going to study about the security aspects of NoSQL database, right? Before we move on to the NoSQL database, first let's recall what you have studied in relational database security, right? So when it comes to relational database security, they have a well-defined security mechanisms, right? They have a proper authentication mechanism, they have auditing tools, they have transaction reliability, they have a better data integrity. All these things they are in the inbuilt features of relational databases. For example, if you want to download a MySQL, you used to download a MySQL, and you have to create a password and username for it. Each time when you're trying to log into the MySQL database management system, you have to give the username and password in a way that authenticate you, right? And you have keys and constraints to support the data integrity of your system. There are auditing tools available in order to do audits inside the system. What do you mean by audit? What is auditing in security? You might study in this database security model, right? What is auditing? Did you study about audit trails? No?
No.
Okay, all right. Audit means, okay, I'll give you a quick brief idea about what is an auditing. Usually, when when you log into the system using your password and username, there will be a audit log will be created for you, right? Each operation that you performed inside the system will be logged. If you read something, it will be logged. If you download something, it will be locked. If you update something, that will be locked. So in all for each user, all these locked data will be there. So in between, if some tampering activities happen, or if some unauthorized modification happen to a database, using these system logs, you can do an audit and you can find out, okay, who made this change, right? That is what auditing means. So in relational database, for example, PostgreSQL, there is a feature called PG audit available to do this database auditing. There is already a feature available to do the auditing. You, you don't need to write, sorry, you don't need to write an implementation to do those auditing, right? That is what audit means. And transaction reliability. We have already discussed, it support ACID properties. So it will give a proper consistency in the transaction, right? So all these features are available inside the relational database management system. In addition to that, there are 3 access control mechanisms were available. I hope you all studied these things, right? Discretionary access control, mandatory access control, and role-based access control mechanisms. Did you all study about these access control mechanisms?
Yes.
Yeah. So there are access control mechanisms available for the relational database management system. When it comes to discretionary access control, you can grant and revoke privileges from user to access some data. When it comes to mandatory access control, you can set different security level, and based on the user's security levels, they can access their authorized data. When it comes to role-based access control mechanism, you can create roles and you can assign privileges to those roles, and you can assign users to those roles, and the users will get those privileges, right? So there are different types of access control mechanisms were available. So all these are supported by relational database management system. They have a good authentication module, they have a good auditing capacity, have a high data integrity and transaction support. They have these different types of access control mechanisms. All these features were available in inbuilt. That means it's already available. If you download the relational database management system, that will support these features, right? So that is about the security aspect of relational database. Now let's see the NoSQL security aspect. When it comes to NoSQL security, most of the NoSQL database, they are not provide inbuilt security features. That means you have to, as a developer, we might need to implement these security features in the middleware, right? Rather than we already have that features and we cannot use it, you have to implement them and you have to use it, right? So in the inherently, these type of NoSQL database, they don't have these security features, right? And another thing is, even though relational database management system have these high security, you know that still they are prone to attacks, right? There can be SQL injection attacks, there can be API attacks, there can be different types of attacks can be possible in relational database management system. All these relational database management system related attacks can be possible in NoSQL databases as well, right? That's another story. But other than that, because of some characteristics of NoSQL data, there are some additional NoSQL security attacks could be possible, or additional NoSQL issues could be possible. So what are those characteristics? There are, because the databases are unstructured and because the databases are distributed, there are some issues, right? Other than these, relational database managements are prone to some attacks that are also possible in NoSQL database. But because of, specifically for the NoSQL database, because of some characteristics of NoSQL database, they are prone to some special attacks, right? Those characteristics are unstructured nature, distributed computing environment, cost of security in contrast to performance, and no strong consistency. Right? We'll see one by one. First one is unstructured data. So when you have an unstructured data, that means you don't know what you will get. When relational database, we know what we will get. But when it comes to NoSQL data, we don't know what we will get. So if you don't know what you will get as a data, validating those data and sanitizing those data is difficult. So that is one of the issues that will be caused by this dynamic nature. And distributed nature, that since the database is distributed, the issues related to network will also be an issue in our database. And cost of security in contrast to performance, right? Since our major focus is in performance, in order to reduce the computational overhead, we might trade off between the security and performance. That's the next issue. And the fourth one is no strong consistency. That means since we are supporting the eventual consistency, that means the NoSQL is supporting the eventual consistency, the database might access the stale data. That means not updated data. So because of these specific features of NoSQL, we might come across with different challenges, right? So those challenges are threats posed by the distributed nature, and issues with the identification and authentication, issues with the authorization and access control, and issues when it comes to data is moving across the network, and issues with the users privacies. So these are some major security challenges that is there for the NoSQL database because of its characteristics, which we have discussed in the previous slide, right? So under these 6 categories, we'll study each category and we will find out, okay, what are the issues? How can you overcome those issues? All these things we will study in the next lecture, right? So do you have any questions up to now? So in the next class, we'll study we have categorized the major challenges, and each challenges we'll study in the next class, right? So do you have any questions or any queries up to now based on what we have discussed?
No.
No. All right. Okay. So if you don't have any issues, in that case, then we can wind up the lectures.
Recording stopped.
All right. So, okay, let's continue the rest, the security challenges in the next class. So that's it. And thank you for listening.
Thank you.
Thank you.
Thank you.
Okay, I'll end the meeting.